Okay, so our notes are on parent graphs. And just like all of us have parents, we can view graphs as having parents, meaning that there's this general shape within different types of equations that all other shapes kind of come from. For example, a parabola, we saw in Math 2 Honors, looks something like that, right? And all parabolas look like that. And so we pick one graph, we call it the parent graph, and say, well, all other graphs are coming from that one parent because they all look alike, okay? And then we come up with another graph, maybe an absolute value, which is a V shape, and say, well, okay, all absolute values, they all look alike, and so they all come from some parent. And today we're going to look at those parent graphs. There's going to be 4 different kinds of equations we'll look at: linear, quadratic, linear absolute value, and exponential. And we're just going to focus on the parent graphs, and then we'll go from there and look at all kinds of graphs that come from these parents in future lessons. Okay. So our first one is y equals 2/3 x. All linear graphs, you remember, have a slope, and that's what that's what gives it to it. So it's a line. You need at least 2 points to graph a line, and there's a slope related to it. And so we say that 2/3 is our slope, right? And if we were to graph that, there's a couple ways to do that. Can anybody give me a point that this graph goes through? And give me a point that does not involve fractions. 3, 2. Okay, so if you're saying if you plug in 3 for x, we'll get 2 for y, and we can check that out. If you go 2/3 times 3, which is 3 over 1, you can multiply straight across, get 6 over 3, and you reduce that, you get 2. So 3, 2 is a point. Anybody give me another point it goes through that does not involve fractions? And here's you get to pick the x value, and when you do this, you got to realize I need to divide it by 3. So you pick something that's divisible by 3, and so it worked when we picked a 3. What else is divisible by 3? Chase, 6. Okay, so if I plug in a 6, what do we get, Chase? 6 and 4. Okay, because 6 times 2, you multiply the x and the 2 together, is 12, and then you divide by 3. So 6 times 2 divided by 3 is going to be 4. You get 6, 4. What if I plug in 0 for x? That's a nice one, right? It's always nice to plug in a 0. So I'm going to plot these points. So we got 0, 0, 3, 2, and 6, 4. And here's our line. And you see the slope in that line. If you pick, if you start at a point and slope is rise over run, and our slope is 2 over 3. So if I go up to right 3 from any point, I end up at another point on the line. And I can do it again. So I go up to right 3, and I end up at a point on the line. Or I can even go down. From this point, I could go down to left 3, and I end up with a point on the line. And so that slope gives that shape to that line. Okay. If you have something that's not straight, it doesn't have a constant slope. And so a curve like a quadratic is not going to have a slope. And so be careful not to think it does. And so y equals x squared is a really basic quadratic. If I plug in 0, what do I get? If I plug in 2, what do I get? 4, right? And I'll plug in a -2. I get 4 again. And so you have 0, 0, 2, 4, -2, 4. And what a parabola does have is something called symmetry, around the axis of symmetry, and careful to make it look like a curve, because when we get to absolute value, it's going to be more of a V shape. So you don't want it pointed. You want it curving through that. Okay. And so there's our parabola. Linear absolute value. It makes what kind of shape? A V shape. And so if I plug in a 0, what do I get? 0. And what else could we plug? We want to kind of avoid fractions when we're graphing on these lattice points. So plug in a 3 because we're dividing by 3. And what do we get? Okay. And so I'm going to plot these points. So we got 0, 0. We got 3, 2. Okay. And I want to bring out the V shape. So I want to pick another value for x that brings out the V shape and that doesn't avoids the fractions, right? So what might work? -3. And when you do that, absolute value makes what you plug in there positive. So here's what happens. You get 2 over 3, absolute value of -3. And the absolute value of -3 ends up being +3. So you get the same answer as if you plugged in a +3 or a -3. And so you end up with a 2 again. So it's, sorry, -3, 2. And so this is made out of lines, so it does have a slope, but it's also kind of like the parabola because it's got symmetry. It's got this vertex, and one side matches the other, right? Just kind of a reflection. And so when you're graphing this, if you could know where the vertex is and know what the slope is, like slope here is 2 over 3, so I can go up 2, right 3. And then I can, because I know it's symmetric, I can go up to left 3 to get to that third point. And that can be helpful to know when you're graphing these things. And the last one is an exponential function, y equals 2 to the power of x. If you plug in a 0, what do you get? Not 0 this time. You get 2 to the power of 0, and 2 to the power of 0 is 1, so 0, 1. So this one's a little different than the other 3 graphs. Its parent graph, all the other parent graphs go through 0, 0, but this one doesn't. This one goes through 0, 1. When x is 1, what is y? 2. When x is 2, y is 4. Okay. What happens if x is -1? You get 2 to the -1. Do you remember how to do negative exponents? You get 1 over 2. And I'm going to do this just to show you what happens here. So you get right about there. What if you do -2? What is 2 to -2? 1 over 2 squared, which is 1/4. Will it ever get down to 0? It just get closer and closer and closer to 0. So this graph, if you go to the right, it grows really quickly, grows exponentially. But as you go to the left, the growth really slows down and kind of levels off. And you have what we call a horizontal asymptote here. So it's never going to go below that line, and actually it'll never touch that line. It'll just get closer and closer to it, and it gives shape to our graph. All right. So I have 4 graphs below this, and I want you to do what we just did. Okay, I want to give you a few minutes to find 3 points and graph it. Okay, so for this first one, it's helpful to solve for y. So I'm going to do that first. I'm going to write y equals negative 3x. So I subtracted 3x from both sides because it's a graph. You're graphing it in terms of x and y. So if you solve it for y, it's going to be a little easier to work with. And then you just pick some points. I know it's linear. I know it's going to be a line because it just has an x and there's no absolute value. There's no x squared. And there's no, it's not, the x is not the exponent. It's, it's just its own base. So you got negative 3 times x. And so you pick something. 0, 0 is a great one. And actually all parent graphs that are lines go through 0, 0. And so that's one point that I'm just going to use. And then what I'm going to do here is rather than just pick any x value, I'm going to use the slope. Because eventually this is what you're going to want to do. And our slope is negative 3 over 1, which means I'm going to drop 3 for every 1 I go to the right. And so from 0, 0, I'm going to drop 3 and go right 1. I'll drop 3 from that point and go right 1 again. And so I got my 3 points pretty quickly there using the slope. And then I can go back to the chart and write those in. So I got 1, negative 3, and 2, negative 6. Now you guys could have chosen other numbers as well. Did anybody have a different one that you guys use? Those are the ones we use? Okay. So the next one I know is quadratic. So you want to bring some information when you're graphing these because there's all kinds of graphs. And to know what it looks like is going to be helpful to you. It's got that x squared, so I know it's got to be a U shape. I also notice it's got a negative in front, which tells us what? Anybody remember? It's going to be upside down, okay? So this is an upside down U shape, and I'm using this before I even start the problem. So I know I should end up with an upside down U shape. And then you'll learn over time the parent graph for the parabola goes through 0, 0, and you could try it out. If you plug in 0 for x, you get 0 for y. And that's our vertex. And there's this upside down U that's going to go through that. And beyond that, I need to pick an x value. There's no slope with this right here because it's a curve. It's not linear. And so I'm going to pick 1. And if I go through this, I get negative 3. I'm plugging in a 1 for x. And you follow order of operations. You got to do the exponent first. So 1 squared is 1. So this is negative 3 times 1, which ends up being negative 3. But if I know that 0, 0 is my vertex, and this is a parabola, then I know there is a matching point on the other side because it's symmetric. So I get that third point for free. And that would be at negative 1, negative 3. And you could plug in a negative 1 and you'll see that negative 3 is what you end up with. The next one has an absolute value, so it's going to be a V shape. V's are made out of rays is what you call them, but out of lines. Okay, and so I can use a slope here. I need a starting point though, and really the vertex. And all the parent graphs have the vertex of, all the V shapes have a vertex at 0, 0. So if I plug in 0 for x, I'm going to get 0 for y, and that's the center of my graph. Is this V going to open up or down? just like the parabola, we had the -3 in front. This negative in front flips it over, reflects it across the x-axis, so it's going to open down. And so even if I didn't know that, I'd look at the slope. The slope is -3/1, and so I'm going to go down 3, right 1, and so that's the right side of my V shape. And so then the left side of my V shape will look like that. So I got 1, -3, and -1, -3. Now some of you may be thinking, hey, couldn't we have done that with the parabola? Got a -3, couldn't I have just gone down 3, right 1? Okay? Anybody have that thought? But I'm saying there's no slope here. Okay? And don't do that just because it will mess you up in the future. If you try y equals 1/2 x squared, that 1/2 is not a slope at all. Okay? If you go up 1, right 2, it's not going to land on that parabola. But if you have y equals 1/2 absolute value of x, and you go up 1, right 2 from the vertex, you'll land on it. So just be careful. Sometimes it'll look like it works, but it won't always work here. So if it's curved, think no slope. Don't worry about it. There's no constant. But here, this is made out of line, so we can use the slope. Okay. And then the last one. So here's what you want to know about the parent graph. These parent graphs never touch the x-axis. They're exponential, and no matter what you plug in, it's always going to be bigger than 0. Also, these parent graphs always go through not 0, 0 because it's not on the x-axis, but 0, 1. All of them do. And so there's this upward growth. So I'm just going to pick a point. I'm just going to plug in. If I plug in a 1 for x, I get 3 to the first power, which is 3. If I plug in a 2, I get 3 to the second power, which is 9. And plot those. Okay, something like that. So this next one, we got a linear one, 5x equals 2y. First thing you want to do is solve for x or y. What's the pattern here? All these are solved for y. So we want to solve for y. So I'm going to turn this thing around. I'm going to put the 2y on the left side, 5x on the right side, divide by 2, and get y is 5/2x. Okay. It's a parent graph. So what do we know about lines? All lines that are parent graphs go through what point? 0, 0. You could try it out. So we need a starting point. And then because it's a line, we can use our slope to find other points. The slope is 5/2. So if I use that slope, do I go right 5, down 2, or what do we do? How do I use that slope from that point? Up 2, over 2, up 5. So up 5, 1, 2, 3, 4, 5, right 2. So that's going to be at 2, 5. If I go up 5/2 again, it's going to be off the graph. So can you find another one that would be on the graph? So we can go down 5, left 2, and that would work. You can always go the other direction. Okay. 2x squared. It's a parabola. All parabola parent graphs go through what number? Where's a good starting point? 0, 0. This one going to open up or down? Up, because it's got a positive 2 in front. And then you just pick a point to the right, and then there's going to be a matching one to the left. So if I pick like a 2 for x, what do I get for y? We get 2 times 2 squared, which is 8. And then there's going to be a matching one on the left side because it's symmetric, gives it that U shape. And there we have it. And absolute value, you know, it's a V shape. And we need a starting point. It's a parent graph. Later on, I'll tell you how to recognize it as a parent graph. But it's a parent graph, so it's going to go through what point? 0, 0 again. And what's the slope of this thing? 1. There's a 1 in front, so you think of it as 1 over 1. So I can go up 1, right 1. And then the last one is exponential because the x is in the exponent. And so there's some things that we need to carry with us. All exponential parent graphs, this is only on parent graphs, don't touch the x-axis. Stay above it. And they go through a starting point. Where's that starting point? Not 0, 0, 0, 1. Because if you plug in 0, you get 1. 4 to the power of 0 is 1. And then you're just going to want to pick things to the right, otherwise you won't get integers. So if you pick a 1, you get 4. You pick a 2, you get 16 off the chart. So I'm just going to graph the 1, 4. So something like this. Okay. So those are the 4 key shapes that we're looking at in Unit 1. There are a couple special cases I want to address, and then we'll be done with our notes. And those are of lines. So typically, a line has an x and a y in it, but there are sometimes you won't run into that. So, for example, y equals 2 is a special case of a line. And this is saying whatever point you pick, the y value has to be stuck at 2. Okay, so if x could be whatever you want, but y is stuck at 2. So if x is 1, y is 2. So if I plot that 1, 2 right there. If x is 5, y is 2. So if I go 1, 2, 3, 4, 5, y is stuck at 2. And no matter where it is, y is stuck at 2. And you see this starts to create this horizontal line at a height of 2. Just stuck there. X equals -3 forms another line. But here, the x value is stuck at -3. Y can change to whatever we want. And so if y is 1, x is -3. If y is 3, it's still at -3. So x is stuck at -3, and you end up with this vertical line going through x equals -3. Some people get confused with these because they say, well, here's a y, so it should, and the y-axis goes up and down, so it should go up and down. But that's not true. Y is fixing the height. So the height is stuck at 2 as x moves left and right. Okay. I'm going to stop there on the notes, and this should carry you through the first 15 problems on your homework. Okay, they're just like this. And then again, don't forget there's that survey, that just get to know you kind of questions that I have for you. There's even one that you can ask me a question and I will be answering back to you, okay?